Hello and welcome back to part 2 of the chain rule. We're just going to finish up a few of the examples that we did not do yesterday, and then we'll wrap this section up. So let's continue to look at how we would simplify derivatives. Example 6 says to find the derivative of f of x equals x squared times the square root of the quantity 1 minus x squared. Now before I do any derivatives, the first thing I would do is I would rewrite this as the product and get rid of any fractional or any radicals and write them as fractional exponents. So I can rewrite this as x squared times the quantity of 1 minus x squared raised to the 1/2 power. Now when I go to do my derivative, or f prime of x, I see that I have a product rule of x squared and then the quantity of 1 minus x squared raised to the 1/2 power. So I'm going to take the first and multiply it by the derivative of my second. Well, the derivative of my second, I am going to have to apply the chain rule. So I'm going to pull that 1/2 down up front. So I have 1/2 times the quantity of 1 minus x squared. I'm going to raise that to the negative 1/2 power. And then I'm going to multiply it by the inside. The derivative of the inside is a negative 2x. And then I'm going to add that to the second, which is 1 minus x squared to the 1/2 power, times the derivative of the first, and the derivative of x squared is 2x. I do want you to go ahead and simplify this. So this is going to give us, I have a negative 2x times x squared times 1/2. Well, my half and 2 are going to cancel. I will still have a negative out up front, and x squared times x will give me x cubed. This piece here is going to go to the denominator because it has a negative exponent, and this is really the square root of 1 minus x squared. And then I'm going to add, it looks like 2x times the square root of 1 minus x squared. So this here would be my simplified derivative. And you could go ahead and rationalize and get common denominators, but you can leave it like this for now. Example 7, we want to find the derivative of f of x, which equals x divided by the cube root of the quantity of x squared plus 4. So again, I would start out by rewriting this and getting rid of the radicals. So I really have x squared plus 4 to the 1/3 power in my denominator. And now when I go to find f prime of x, I can use my quotient rule. And my quotient rule says the bottom, which is x squared plus 4 to the 1/3, times the derivative of the top, which is 1, minus the top times the derivative of the bottom, and I am going to have to apply the chain rule. So this will give me 1/3 times the quantity of x squared plus 4 to the negative 2/3 times the derivative of the inside, which is going to give me 2x. And then I'm going to divide the whole thing by the quantity of x squared plus 4 to the 1/3, and then I'm going to square all of that. Now the only simplification that you may want to do here is maybe kind of combining your exponents and simplifying like this x with this x. Okay, don't risk the error of making too big of a mistake on the AP test. So what this is going to give us is x squared plus 4 to the 1/3 power minus, it looks like we have 2x times 1/3 times the quantity of x squared minus 4, all divided by the quantity of x squared plus 4 to the 2/3 power. And again, you can further reduce that. You have some fractions up here. Oops, and I did leave the exponent out. This should be to the negative 2/3. But don't try to do that on the AP test, please. Example 8, we're given that y equals the quantity of 3x minus 1 divided by x squared plus 3 all raised to the second power. This is a classic chain rule. So we're going to start out by differentiating or finding y prime. And we're going to take the derivative of the outside, which is going to give us 2 times the quantity of 3x minus 1 divided by x squared plus 3. And we're going to raise that to the first power. Now we have to take the derivative of the inside. And to do the derivative of the inside, I am going to have to apply the quotient rule. So I have the bottom, which is x squared plus 3, times the derivative of the top, which is 3, minus the top, or 3x minus 1, times the derivative of the bottom, which is going to give us 2x, all divided by the bottom squared. So, to simplify this, we have in the numerator 2 times 3x minus 1 times, and I'm just going to distribute this 3 onto this piece here. So that's going to give us 3x squared plus 9. And then we're going to subtract, and I'll do the same thing here. I'll distribute this on into this piece. So then that's going to give us minus 6x squared minus 2x. And we're going to divide this whole thing by the quantity of x squared plus 3. And I do have an x squared plus 3 here and an x squared plus 3 being raised to the second power here. So that means that the exponent on that is going to be to the third. And at this point, I would probably leave that right here. However, realize that you could go ahead and simplify, FOIL these out, subtract your answer here, and get a more simplified numerator. The last thing we're going to look at are trig functions in the chain rule. These right here are your 6 trig functions and their derivatives. As we mentioned before, this is something you do have to know, okay? And I wouldn't worry so much about this notation as I would just know what the actual derivative of sine is and cosine and tangent and so on. And then know that if you have anything inside of you other than x, that you are going to have to apply the chain rule. So example 9 says that a is equal, or for part A, we have y equals sine of 2x. So if we want to find y prime, we're going to take the derivative of the outside piece, which is the sine x. So the derivative of sine x is cosine x. And we're going to multiply it by the derivative of the inside. And the derivative of 2x is just 2. So we end up with 2 cosine x. For part B, we're going to do the same thing. We're going to do the derivative of the outside, which is cosine. So the derivative of cosine is a negative sine. And the inside stuff stays the same. Then I have to multiply by the derivative of the inside, and the derivative of the inside in this case is just 1. So we're left with a negative sine of the quantity of x minus 1. And then for part C, y prime, derivative of the outside is going to be tangent. So derivative of tangent will give us secant squared of 3x, and then we're going to multiply that by the derivative of the inside, which is going to give us 3. So our final derivative then will be 3 times the secant squared of 3x. Now in example 10, this is very similar, however we have a slightly different notation. Sometimes when we are squaring the x term or squaring the trig function, it gets a little confusing. So just to reiterate what all of these mean, in part A, this cosine of x squared, the x squared, if you want to think about it, is really like in parentheses. So if I take the derivative, y prime is going to equal derivative of the outside, which is a negative sine of x squared, times the derivative of the inside, which is 2x. So this will give us a negative 2x times the sine of x squared. Now for part B, B is different in the fact that cosine squared of x is really equal to the cosine of x all squared. So now this is another form of the chain rule. So this tells us that y prime is equal to 2 times the cosine of x. And we're going to raise that to the first power. Now I have to take the derivative of the inside, or the derivative of cosine, which is a negative sine x. So when I simplify this, I really have a negative 2 times the cosine of x times the sine of x. And this here is the final piece. And then for part C, I'm going to rewrite this as the cosine of x to the 1/2. So when I go to find y prime, I really have to do the chain rule, which is 1/2 times the cosine of x to the negative 1/2. Then I have to multiply it by the inside, or the derivative of the inside function, which would be a negative sine x. And if we simplify this, we have a negative sine x in the numerator, and we're going to divide that by 2 times cosine of x to the negative, or to the 1/2 power, or you can go ahead and just write that radical in there. So this here would be our final answer for part C. And our last example is where we're going to have to apply the chain rule a couple times. So we have that our f function is equal to sine cubed of 4t. Now if we rewrite this, this is really equal to the sine of 4t cubed. So when I go to take the derivative, f prime of t is going to equal the derivative of the outside, which is going to give us 3 times the sine of 4t. And that derivative of the outside is really pertaining to the stuff in parentheses to the third power. Then I'm going to multiply that by the derivative of the inside, and the derivative of the inside is pertaining to the sine of 4t. So the derivative of sine is going to be cosine of 4t, and then I have to go and multiply that by the derivative of the inside of the sine of 4t, or the 4t part. So in that case, I have 4. So now when I simplify this, we're left with 12 times the sine of 4t times the cosine of 4t. And I apologize, when I brought my 3 down right here, I should have also squared that up here. So these are really sine squareds of 4t. So again, I'm sorry. So this right here is our final answer. And that concludes this video. So here's today's fun fact. Have a good one.